So now let's see how we use the solution to solve an example problem. So let's imagine a 1 kilogram mass on a 16 Newton per meter spring displaced 10 centimeters and released at time equals 0. Okay? So now we've done most of the problem. We're not going to go back and write the equation of motion and guess a solution, plug it in. We know that the general form of the answer is A sine omega naught t plus phi. So really the point of this problem is to use our initial conditions to get the actual amplitude and the actual phase for these initial conditions. So let's start with position. Let's figure out what do we know. We know that we lifted at 10 centimeters and at time equals 0 the position was 10 centimeters. So we can write that mathematically like this. We can say x at 0, x at t equals 0, equals A, that's one of the things we're looking for, sine omega naught. See, omega naught is the square root of k over m. That's 16 over 1. So that's going to turn out to be 4 t. But time is 0. So actually, you don't even put that there. It's 0 plus the phase. That is 0 plus phi. So that is equal to 0.1 meters. I'd recommend staying in MKS units. Okay? So A sine phi is 0.1 meters. That doesn't really help us solve anything because it has both A and phi in it. So we also need to use the velocity. Right? So in addition to knowing the position at time equals 0, we know that it was released from rest, so we know the velocity at time equals 0. So let's see, if we do the derivative real quick, we know it's A, sine goes to cosine and it pulls out an omega. So there's an omega naught, square root of 16 over 1. Sine becomes cosine. T, but again, this is at time equals 0. So this part goes away, right? You have 0 here. Plus phi equals what? The initial velocity was 0. This one also has two terms in it, but this you can do something with because it's equal to 0. So is A 0? No. A can be 0, but that's a trivial solution. Is 16 over 1 square root 0? No, that's 4. So the cosine term has to end up being 0. So where is cosine 0? Cosine is 0 when the argument is pi over 2. Right? So this requires that the phase be pi over 2. So even though this has two of the terms in it, this allows us to solve for one of them because the amplitude can't be 0. So now we know phi has to be 0. Then we come back over here and we say A sine, and if phi is pi over 2, we put pi over 2 there, and that's equal to 0.1 meters. Well, the sine of pi over 2 is 1, right? So if that's 1, then we have our answer that the amplitude is 0.1 meters, like that. And then the whole answer, therefore, is x is 0.1 meters sine 4t plus pi over 2. That would mathematically describe the position of the mass at any time relative to 0.